Looking at section B question now, question 7. I'd like, for a section B question to take a scan down through it and just see what type of question it might be. So if we look here, speed camera is located at P, which is 40 meters from the nearest point, A, on a straight road, that's level ground. The camera monitors a moving car that's going along the road from point B to A, which are 100 meters apart, and C is a point on the road which is 30 meters from A. So I can fill this into my diagram. They want me to let S be the distance of the speed camera to the car after t seconds. So that there'll be a formula there because it depends on where the car is or what time it is, as to what the distance is. And let X be the distance the car has travelled from B at that instant. The speed of the car is given by this formula. And I want to see, is this a functions question? Is it differentiation? Is there integration involved? So I'm going to take a quick scan down through. So it looks here to me like there's certainly going to be some sort of calculus maybe involved because of this dx dt here maybe. Speed, they want me to find the speed in meters per second. So, they've given me a formula for speed that doesn't have a variable. So I don't know if I can use a formula in order to find the speed. The only other option there for me that I can think of at the minute is to use speed is distance divided by time, perhaps. Or sorry, they want me to find the time. So that's, I have the option of hopefully maybe doing some integration or differentiation or just using basic, time formula. Sorry, time is distance divided by speed. Then they want me to express the distance, and I know what I'm looking for, between the car and the camera. Now I certainly think they just want me to differentiate here. So find ds dx, so that should be straightforward, me differentiating something hopefully. And then hence find the rate of change. Okay, that's definitely some differentiation there as well with respect to t when the car is at C. So I wouldn't be surprised if that's find the rate of change. And they've talked about ds dx and earlier on in the question they've talked about dx dt. I wouldn't be surprised if that's a chain rule question. And further on here they mentioned some integration. So I certainly know this is a calculus question, but it probably could start off with either functions or something quite straightforward. So they've given me a bit of information. I'm going to do a little diagram myself where that's A, that's C. The car is travelling over here from the point B. This is 40 meters, the shortest distance here from the camera, and they want me to consider S to be the distance between the camera and wherever the car is, depending on where it is along this path here. They've told me that A and B are 100 meters apart, and they've told me that A and C are 30 meters apart, which means here and here is 70 if I need that at any point. And that's probably about, they want me to consider, and I said this already, X be the distance the car has travelled along here from B. So if they want me to find time is either distance divided by speed, or, if I can't do this, I'll maybe try and use some sort of calculus to, if there's a t involved in a formula. So time is distance, which here is 70. Because they want to find the time it takes the car to reach C. So that's 70 divided by the speed. Well, they gave me a formula for speed. They said dx dt is 25, and I end up with the answer 2.8. And if I go back to the questions, they talk about speed as in meters per second, so that must be seconds. That's part 1. Part 2 of A. They want me to express the distance between the car and the camera. So I'm going to go back here. They want this expressed here. Now, if the car has travelled X meters along here, then this must be 100 minus X here. If that's 40, looks like I can use Pythagoras Theorem. So part 2, I'm going to say that S squared is equal to 40 squared plus the 100 minus the X to be squared. And just working that out, I end up with 1,600 plus, you can take this to the side and work it out, 10,000 minus 200 X plus X squared. Clean that up further. That's X squared minus 200 X plus 11,600. And then I have the square root. Now, S is plus or minus the square root, but distance can't be a minus, so we're going to go for the plus square root of X squared minus 200 X plus 11,600. And that is what they actually asked me for in the question, so I know I'm fine there. Part 3, they want me to find ds dx. Now, they want me to differentiate s in terms of x. I'm going to change the root here to a power. And if it's anything more difficult than what's in your log tables, I'd always suggest using the chain rule. So I'm going to say, right, they want me to differentiate u to the power of a half, where u is x squared minus 200x plus 11,600. And the chain rule says that if I get du dx and multiply it by, ds, this is good practice, ds du, so I'm now saying s is that, where u is that. If I get ds du and multiply it by du dx, I'll get ds dx, which is what they asked me for. So this is actually good practice here now that they've used different letters as to what I'm differentiating in terms of. So I'm going to use the chain rule. So I'm going to differentiate this, and multiply it together. So that is ds du is a half u to the power minus a half times du dx is 2x minus 200. And I need to clean this up. So I have a half multiplied by, now I was the one who created this, so I'm going to replace it, x squared minus 200x plus 11,600 to the power of minus a half times 2x minus 200. And again, I need to clean this up. The minus a half means it's 1 over it, and the power of a half means that it's a root. So the half times this just leaves me with x minus 100 on top, and this can go below and be the square root of x squared minus 200x plus 11,600. So that is ds dx. And the very last part that I'm going to do on A, they want me to find the rate of change of s with respect to t. So that sounds like they want me to find ds dt. Now earlier on in the question, they have talked about, the very first thing was they gave me a formula to do with dx dt. They just made me figure out ds dx. And if I simplify, or if I multiply those two together, I would end up with what they want, which is ds dt. So I'm just going to get dx dt, which they said at the very start of the question is 25. I'm going to multiply it by what I just worked out there, which is ds dx, which is 100 x minus 100 all over square root of x squared minus 200x plus 11,600. So that is that multiplied by that is going to give me ds dt. When the car is at C, while the car is at C, I know that x is 70. Like if I go back to my original diagram, if the car is here, then x is 70. So I can sub in x is 70 into my new formula, throw it into calculator, and I'll end up at minus 15 meters per second.